a problem and we use the same kind of thinking. If we use the same kind of thinking over and over and over again, we kind of get better at it. So not new thinking here. It's like, okay, I got to figure out my u and I figure out my du and I make my replacements. But what's different? Well, when I'm doing an E problem, 99% of the time, that's going to be u sitting right here. Not all the time, but we're not doing tricky. We're not going to try to do special super tricky ones. We're going to have other techniques for that. If that's u, run the work over here, figure out what you need to make my du work. Extra constants make the world go around. Anything you multiply by in here, reciprocal out there. Rewrite in terms of u. Antiderivative doesn't look like you did anything because the antiderivative of e to the u is e to the u. And go back to x. That's how the E problems work. That's how we do the antiderivative of E raised to a power. Let's do a couple more E ones and see how we do. Let's try this one next. I want to do the antiderivative of e to the x squared times x dx. Okay. See if you can figure out how you're going to make that work with a u substitution. What does this say? Who is bothering me? uh-huh. Like all of our other u substitution problems, and I've kind of said this from the beginning, if everything isn't kind of organized perfectly in the beginning, u substitution doesn't work. So u substitution is not a guarantee. It's a guarantee when you're working with me, that if we're practicing it, it's going to work. But in terms of in the world of calculus, you can't just grab any old antiderivative problem and be like, oh, I'm going to do u sub. U substitution doesn't always work. It works on certain combinations of things, but if you don't have that combination of things, you're kind of out of luck. You got to use some other technique. Okay. U is always what's in the power of the E. When we're doing the E problems, that's the part that makes the E problems easier, I think. Even less thinking about where to go for U. When you see an E antiderivative problem, you're like, okay, E to what power? That power is, I'm going to try a U sub. That power is going to be my U. Write my du out. Look at what I want. This is what I want. I want this. I want this. And make that happen. Now I'm all happy because I have a 2x dx. But I gotta be legal. Keeping it legal. 1/2 out front. E to the u du. We are almost done. We barely have to do any more work. The next step really doesn't feel like we've done anything. we technically we have taken the antiderivative of e to the u. It just happens to be e to the u. It's like 5 times 1 is 5. It doesn't feel like you did anything. Well, I did. I multiplied by 1. It just didn't change it. The antiderivative of e to the u is e to the u. And so this is 1/2 e to the x squared plus c. We switch back out of u into terms of x. Maybe I'll do some kind of like pick your own, choose which problems you want to do on the quiz. That would be interesting. If I gave you like a bunch of problems and I said, okay, you have to do 5 of these. Yeah. Yeah. Well, I mean, I would choose the original. Yeah. Yeah. Like I have some action in there. Yeah. So I would have some kind of like here's a set of problems. You have to do like 5 of them. Okay. Sort of thinking about that. They're annoying to grade. It's easier for you. I'm thinking about it. Because honestly, that doesn't, yeah, I kind of like that idea, but I would probably make it so you have to do at least one that was either a natural log or e. Like I would make you do at least one of these newer kind.
How do you say we have to do one of each type?
You have to do one of each type, and have a couple options for each one.
You get section by section of the different types you taught us.
Okay.
You do 5, 5, 5, 5.
Okay.
You choose one of each column.
Okay. I'm thinking. I'm not. So you have to do a U. You'd probably do yeah.
Okay, how this? You could do 2 in the top. And then
Yeah,
do the rest.
I probably would give you like a couple regular U sub, one that would, because I'd probably have one with a negative exponent and one with a fraction. Like those are kind of the different things. And then a fundamental theorem one, and an E one, and a natural log one.
See? That's 5. That's
Yeah.
tier 5.
Okay.
And we get the 2.
That sounds like a plan. All right, one more. Ready? Say yes, we're ready. We love this. We love calculus. Are you going to miss me? Yes. Yes. You're going to miss math every day? You're going to be like, it's 2 o'clock. I feel sad. Why do I feel sad? Oh, I miss Mrs. Wilcock. I wish I was doing calculus. I'll see like cars driving past my house. You guys will be like stalking me, like, I have my calculator. Nope. Nope, sorry. Okay. I threw the final curviest curveball at this one. Make it happen. Make it work. Like, what? Look how fun that looks. Just show people your paper and be like, look what I did. They'll be like, I have no idea what you're doing. Anything with an E makes you look smart. Oh no. You're so awesome. Okay. Do, 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 do. Do, 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 do. Do, 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 do. How are you gonna make this happen? It's not that hard. You're probably like, I can do it. This is what I want. I want this. I have a 5, but I want it to be a 3. 5 times something gives me 3. 5 times what? 3 over 5. You got it. That's right. If I solve this equation, the mystery number is 3 over 5. A 3 over 5 times a 5 will make a 5 into a 3. Okay, so 3 over 5 makes this what I want it. Because a 5 and a 3 over 5 will make a 3, and then I'll have the 3x squared dx, which is exactly what I want to be the du. 3 over 5 on the inside, 5 over 3 on the outside. Reciprocal on the outside, multiplied by the reciprocal, so that the bottom line, if you look at the problem I've just written with the green and the red parts cancel out to a 1, so it's not really changing the original problem to put this number and this number there. It makes it look a little different. It lets me represent the problem a little differently, but it doesn't change the overall value. That's what U substitution is about. It's about writing the problem in a different way, a mathematically legal way, but not changing the overall value. We're not changing what the problem's about. We're just making it look different. So 5/3 e to the u du. Antiderivative, like I didn't even do anything. That's why e's are fun. It's hard to mess them up. You just don't change them. And then go back to x. So what was that? That was x cubed. Or yeah, it was x cubed. Right there. There it is. Good job. Now,